In this video example, we would like to demonstrate how to design an omnidirectional antireflection coating with specified color properties. This antireflection coating operates in the visible range and in the wide angular range from 0 to 45 degrees as in the previous example with omnidirectional antireflection coatings. Layer materials are standard with refractive indices 2.35 for high-index material and 1.45 for low-index material. The substrate is glass. The polarization state, average. In this example we specify reflected light color, it must be pink. And we will use D65 light source for this task. In OptiLayer it is possible to use a multi-target. You can combine different types of targets. Let's look how OptiLayer will deal with this problem. First of all, we specify a target function. In this example, the target is the same as in the previous example, antireflection omnidirectional coating. This target contains 3 pages for 3 different angles, 0, 30, and 45 degrees. The spectral points are from 400 to 800 nanometers, with the step equal to 2 nanometers for all degrees. Then we load this target and specify a color target. Let's create our color target. The name of the target will be color pink. We can specify color space, in our case it will be chromaticities. The number of targets will be 6, because we have 3 angles, 0, 30 and 45 degrees, and we need to specify 2 color points, x and y coordinates for every angle. The characteristic is reflectance and polarization state is average. After that we go into preview page, where we can see our target point for all angles. The triangle on the screen. Our color point and chromaticities color space, which we want to obtain, have coordinates 0.4 for x coordinate and 0.3 for y coordinate. So, we return on spreadsheet page and specify these values for our target. Then we can again watch the preview and see our color target. As you can see, the color is pink. So, finally we can load this target. In real life we often deal with different light sources, not with uniform distribution. So, we need to add the light source. In our example it will be D65 light source. We add this source from OptiLayer catalog and load it in the program. After that we load substrate and 2 layer materials with refractive index 2.35 for high index material and 1.45 for low index material. As a starting design we specify 1 layer coating with its physical thickness equal to 500 nanometers. Then we open analysis window. In this window we can see our reflectance spectral curves for all angles. Also, we can open color evaluation window. And in this window, we will show reflectance color coordinates for average polarization and for angular range from 0 to 45 degrees. When we press Calculate button, we observe our color diagram. Finally, we start design process with the help of Neal Optimization Auto. We observe 20 layers coating, so we can terminate calculation of the design. In Analysis window, we can see our spectral curves, and in Color Evaluation window, we can see our color coordinates for optimized optical construction. If we look at the structure of our coating, we will see that it has many thin layers, so we need to remove them using Thin Layer Removal option. In this option we specify the thickness of the thinnest layer. In our example it will be equal to 10 nanometers. After using this feature, we obtained an 8-layer solution, without thin layers. The thinnest layer has thickness about 13 nanometers. If we see at Color Evaluation window, we will see that obtained spectral points have coordinates near our target values for all angles. And we can back to 12 layers solution. In this solution we have 1 thin layer, its thickness is 9 nanometers, but reflectance performance is much better. All spectral curves are below than 3.5 nanometers, and this design also has perfect color characteristics.